days. Okay. I had mentioned anytime there's a natural log in the integrand, most likely we're going to let u equal the natural log of x. Because think natural log, yeah, we write the functions like this, but you could also imagine it's natural log the whole thing to the third power. Okay, which means du is equal to 1 over x dx. Right? Okay, I have 1 over x and dx. I'm going to replace that with du. And this is going to turn into u cubed. So I get to rewrite this, u cubed du. Now we just do the power rule for integration. U to the 4th over 4 plus c, and then we just want to go back. Oh, I actually prefer it like this.
Which way?
With the 4 next to it, but I just wrote it that way.
Oh, you mean like?
Yeah, it doesn't matter. Okay. All right. When we have a fraction, okay, we're either going to make u equal to 2x or u equal to the 4x squared plus 3. It's usually the one that's more complicated. So I'm going to let u equal 4x squared plus 3. Du is going to be 8x dx. Now I don't have an 8x dx. I have a 2x and a dx. Okay. Well, it'll be 1/4, right? Because if I were to rewrite x dx, just the x, if you want to write it as 2x, it doesn't matter, right? 1/8 times the 2 will end up being a 4th. What's that, Noonie? You okay? That's the one power rule that doesn't work. What results in a derivative of 1 over x?
But why is it 1 over u?
Well, this all went away to become 1/4 in du, so it just ends up being 1 over u. Okay, what's the antiderivative for 1 over u? Natural log.
How does 1/8 become 1/4?
Because it's times 2. What's 2 times 1/8?
Wait, why are you multiplying that though?
Well, because if, let's say I want to move the 2 to the front of the integral.
Oh, because you moved it to the front.
Okay.
Wait, how did you get 1 over u, right?
How'd I get what?
1 over u. Does it also work?
Can't I just do a 4th and then have 2x dx?
Yeah, that's
That's fine.
it's fine. Listen, the coefficients are kind of irrelevant, okay? The 2, the 1/8, the whatever, the 1/4, I just automatically throw all that stuff in front because if I want to leave a 2 inside and leave it at 1/8, like it doesn't matter. We're all going to end up with the same answer at the end, okay? Ultimately, we should end up with a 4th. Whether you pull the 2 out or the 1/8 or however you take care of it, we should end up with that at the same time. Okay, so this gives us 1/4. Good. Now, technically, I don't need the absolute value. I don't need the absolute value around the 4x squared plus 3 because it's squared and it's adding something, so it's going to be positive. But if you put them in there, it's fine. Okay, it's better to put them in there when you aren't sure if you need it.
How did you
I'm sick tomorrow.
get?
Okay.
I know, I can figure it out. My
Okay.
What
All right.
period is that?
We have secant theta over 2, tangent theta over 2 d theta. What do we want to let u equal?
Yeah, how do you
to?
know which one? Theta over 2.
So it's theta over 2.
Wait, will it always be the same like that?
If you see a secant tangent with no exponents, it's always going to be what you're taking.
But do you have to say let you, or can you just
No,
say
you can just-
you?
Okay, so here I get 1/2 d theta. Okay, I don't have a half, so I can compensate by multiplying by 2. So I can rewrite this 2 secant u tangent u du. Good. What's the antiderivative for secant tangent? Secant. So 2 secant u.
What? Wait, I'm low-key understanding it now.
Okay. Now, I'm going to show you a shortcut. I had mentioned last class, there's a reason you need to know the long way, and that's because you can't always use the shortcut. The shortcut you can only use if the derivative of u, the inside part, is a constant. So, for example, what was the derivative in the last one?
1/2.
1/2, basically, right? So I could just go right to the antiderivative for secant tangent, which is secant, of theta over 2. And then what happens if I divide by the derivative? If I divide by 1/2, that's how I get the 2 in front. Are you looking?
The colors change.
They're changing, yes. Okay, so in other words, here we take the antiderivative
The antiderivative just needs both.
inside and divide by the derivative. What was that? What was that, Alec?
When you say antiderivative, you mean it's
Yeah, antiderivative and integral are literally the same thing. If I say, what's the antiderivative? That's just saying, what's the formula? Evaluating an integral is where you actually do the whole thing, okay? But yeah, I can say integrate, I can say take the antiderivative. They're one and the same. Okay, so let's look at these kind of general forms. So this one's going to be a power rule. This is kx plus b. K and b are just real numbers. They're just constants, okay? So I want to do the power rule for integration. So I'm going to do the antiderivative. So that's going to be kx plus b to the n plus 1 over n plus 1. And then I have to also divide by the derivative of kx plus b. Well, the derivative of kx would be k. B is a constant, so that just goes away. That's 0. So we're just basically backwards chain rule. We're just always going to divide by the derivative of the inside. Again, if the derivative inside is a constant.
Did you do the first one with substitution as well?
Yeah, all of these work with U substitution.
Do we have to do the shortcut?
Okay, you don't have to do the shortcut.
I didn't use substitution. I thought it was slightly different.
Okay. Okay, so again, you don't have to use the shortcut. It's just there if you recognize. So if I have sine of k times x, what's the antiderivative for
Negative
sine?
cosine.
Negative cosine. So I'll have negative cosine kx divided by what's the derivative of k times x? K. Oh, I forgot to put plus c. These are all plus c's again.
Whatever that is. Oh, it's not
This is
the same.
because this is a different, yeah, this is just the sign. These are just a couple of examples with different functions. If it's e to the k times x, it's going to become e to the k times x divided by k plus c. You should start to see a pattern. We're always going to divide by that constant, right? That coefficient k.
Square.
What happens here? This is going to become 1 over something becomes natural log of kx plus b divided by k.
Hey. Yes.
Okay.
We always overcame.
It's always going to be divided by that coefficient. All right, so we're going to do the shortcut here. Yay,
So
shortcut.
which one's K?
Wait,
Okay.
so we can do this for
So
everything?
what would u be in this case? 2 theta. So what would u prime be? 2. I'm not writing it out as du because I'm not really doing the full u substitution. So I take the antiderivative for cosine, sine, keep the inside the same, 2 theta, divided by 2, plus c.
It's kind of like chicken.
It's backwards chain rule. So remember with chain rule, we have to multiply by the derivative. Here we're just dividing by the derivative. Okay, next one. 6x would be u. So it's going to be, guys,
We did it.
e to the 6x over 6.
Plus C.
Okay. This one becomes 4x minus 1 to the 4th over 4. But I also have to divide by the derivative of the inside is 4. So that's why it's a 4 times 4. Does that make sense? So this will really be 4x minus 1 to the 4th. Sorry, I forgot my... Okay, 3.
So it wouldn't be a lot.
It's not going to be natural log. Why?
Because the X is not.
Because it's not a power of -1, it's a power of -4. Okay, so this is going to be 3. 2x plus 4 to the -3 over -3 times, what's the derivative of the inside? 2. So the 3's are going to cancel. So I have a negative. I'll make that -1 on the top. 2 times 2x plus 4 to the 3rd plus c. Again, all of these can be done the way that I showed you on Thursday. But if you recognize a shortcut, you can use the shortcut. Okay? All right. The only other thing we need to do is now we're going to look at what happens when we have limits of integration. Okay? So what we're going to do is we are going to change the variables and we're going to change the limits of integration. So A and B are we're going to figure out what u is equal to, and then we're going to change this to u of A and u of B and then integrate. It actually is, it's fine. Okay? What are we going to let u equal to here? X squared minus 4. Okay, what is du equal to? 2x dx. Now, I have an x and a dx, but I don't have the 2. So I'm going to compensate by multiplying everything times a half. Okay. I want to change u of 0 and u of 1 into my new limits of integration. So u of 0 is, I'm going to plug 0 in here.
On that one.
Yeah. So -4. And u of 1, so plug 1 in, and that becomes -3. So my new limits are from -4 to -3. That's the key part. Do you see that?
Is that really good? With like,
Well, it simplifies our problem because the nice thing about u substitution with the limits, I don't have to go back and plug in my original value of x squared minus 4. Yes.
I don't understand. So I know you can like. Okay, I I know you said u equals whatever, and then
Yes.
du is the derivative. But where do you get 1/2 du? Or like the other problems are like, well, we have to multiply 1/4.
So this isn't. This has an x and a dx, but there's no 2 here. Do you see a 2 anywhere? No. So I'm going to multiply by 1/2 because I have to.
Why do you have to?
If I have a missing coefficient, I have to.
Where is it missing?
I don't have a 2. Do I have a 2?
Is it down?
You have to replace
Yeah.
du.
I have to replace du with a 2x dx. So if I don't have a 2, I have to compensate by multiplying by
Can you
1/2.
just solve for dx and then plug in dx?
Why would you plug in? The whole point is we're changing it everything in terms of u.
The X is already there. You want to replace the X.
Yeah. Never mind.
Okay, put a star next to it. We could come back to it. Okay, what happens when I take the antiderivative to 1 over u? Okay, absolute value, right? I want to evaluate this. Shh, guys. Shh. Trying to. I know it's last period. Now we plug in. This is when we plug in the top minus plug in the bottom. So we have natural log of absolute value of -3 minus natural log absolute value of -4. No, not with if we know the limits of integration, we don't have to go back and plug in.
What about the plus C?
No more plus C. Okay, so when we have limits of integration, we're always going to have a numerical answer. Okay, good. Yeah, you can leave it like that.
Why is U -3 instead of
Wait, what's that? Where?
-4?
Yeah. No, because I'm plugging. Okay, the nice thing about U substitution when you have limits, we can forget all about that first part. We're literally simplifying it so that you just have to plug in, because remember, these limits of integration are reflecting our new function U.
Okay.
Can we change that to 1/2 our 3 over?
Yeah, you could. Okay. Okay. What are we going to make U equal to here? Tangent.
How do we know? Because the derivative
What?
of tangent x is
Wait, I'm so puzzled.
Okay, when we have tangent and secant, okay, and the same problem, if there's a secant squared, we're going to make U equal to tangent. Because when we do the derivative of tangent, we get secant squared. So all of that goes away, and it's just going to be du. And tangent is going to be u. So I literally have u du. Because the derivative of tangent is secant squared. So I know whenever I have a secant squared in my integrand with a tangent, I'm going to make tangent the u. Now I'm gonna change the limits. So u of 0, so tangent of 0 is 0. And u of pi over 3, tangent of pi over 3. So I get to change this. Okay. Now remember, the whole purpose of that is I don't have to go back to anything in terms of x. This is my new function with my new limits of integration. Okay, so it's u to the first, so that will become u squared over 2. No plus c because we have limits of integration. U to the first power, so add 1, divide by that new. I didn't plug in 0. If I plug in 0, I just get 0. Okay. This next one is similar to the one we had on the homework. Okay. So I want to turn this 9 into a 1. So what do I need to... Okay. I'll multiply by 1/9.
Is you, what is you gonna do? Oh.
What do you think is changing? This is a tangent inverse.
Does the 1/9 not go in the front?
Well, what happens here? 1/9 times 9 will just, that cancels. 1/9 times 9 is 1. 1/9 times x squared will be x squared over 9.
So don't put it in front.
No, because it's just manipulating the.
But you could do it instead by pulling one out, right?
Yeah. Okay. Now, technically, this one, I could do the shortcut at this point. Because what is the inside part? X over 3. What's the derivative of x over 3? 1/3. Okay. So I don't have to change my limits in that case. So it's going to be tangent inverse of x over 3 divided by 1/3, evaluated from 0 to 3. So notice I didn't end up writing out. Now you could do this like the previous ones where we did let u equal x over 3, we du, right? But I see the derivative of the inside is a constant, so I can just do this one. Well, if I divide by 1/3, that's the same as multiply by 3. So we get 3 tangent inverse. Okay, we're going to plug in 3, so that's just going to be 3 over 3. Gives us 1 minus tangent inverse of 0. Where is tangent equal to 1? Pi over 4. So it's 3. Where's tangent equal to 0? 0. So it's just 3 pi over 4. What? Oh, from negative pi over 2 to pi over 2. Oh, here I made this. This should be a u and a du here. Sorry. Okay. So let's say we have a continuous function and we want to take the antiderivative. If I rewrite this, what will my new limits of integration be? Okay, so go from here. What would u equal?
3.
Okay, so what would u of 3 be? 9. And u of 12?
36. How do we get rid of that? Oh, because you derivative?
So a is going to be 9. Here.
How'd you get rid of that? Oh, because it's the limits. I'm sorry.
Yeah, I'm just finding the new limits. Okay, so all you need to do here is figure out u is 3x and then just plug them in to find the new limits of integration.
The inside.
How many points do you think that'd be worth on a quiz?
Maybe 1.
Yeah, maybe.
Maybe 5. Not depending on what
Okay, last one here.
Can I do like 0.2% of our grade?
Okay, last one. Here's my function. Sometimes on the AP exam, they use the capital letter F in place of the derivative, which means when I work backwards, if I'm taking the antiderivative of lowercase f, the antiderivative, will be a capital letter. antiderivative of f is capital F.
That makes sense. That makes sense.
All right, so okay, so I want to figure out which one of these is going to be. How do you get B? It's a good guess, right?
Is it right?
But why?
Are you serious?
Okay,
Because you
Oh,
and
you
2
divide by
x to
2
multiply
because it's
both by
half,
2.
so then it's 7 and 5.
and then what are my limits of integration? U of 5 is going to become 10, and U of 7 is going to become 14. So basically, we get 1/2
That was
For
can't wait for someone to slow it